Good afternoon, folks. Hopefully, you guys have been well. I'm going to get started by talking about the next step of database design, which is converting our ER diagrams into tables. While I'm doing that, if you want to post any questions you may have, I can take some time out and answer those questions. Maybe even show you some examples and diagrams and things. All right, so I think we're going to need this as well. Okay. So, up until this point, we have learned about ER diagrams, which are made up of E's and R's, entities and relationships. Okay. Remember, our entities need primary keys, and our relationships need foreign keys, depending on what type of relationship it is. Remember, one-to-one, one-to-many, many-to-many. You'll add in foreign keys according to the rules that we looked at last time. Okay, so I think I have an example here that I can use. Actually, I think it's in the slides anyway. All right, so what are we looking at next? We are going to look at fleshing out our diagrams and start to think about the actual individual pieces of data that will be stored for each entity. Okay, and so we're deciding basically which fields to create. Okay, fields are also referred to as columns because in a table they are the columns, all right? And they're also referred to as attributes, okay? So we'll look at how to decide those, and we'll also look at what data types are available to use for your fields, all right? So we're going to fill in the details, converting ER diagrams to tables. So just like before, we can just follow a process, all right? This is a very standard process from an idea to a database. We are still in the planning part, but we just need to follow a few steps, and it should be pretty straightforward. Okay, so let's talk about how computers store data, because this is going to help you understand why there are different data types. Okay, so I posted a video here, and you can check that out on your own. All right, and it talks about how anything that you want to represent digitally, you basically need to be able to convert it to numbers. So if you want to display letters, we convert those into number codes. If you want to display music, we do sampling, which takes the frequency of sound at different points in the music and then strings those together. If you want to do an image, we have numbers that represent colors, locations of those colors, all kinds of things like hue, saturation, all that. So everything needs to be represented ultimately by a number in the computer. So those numbers can be reserved for different types of data. Okay. And so I like to give this example now, and I'll keep mentioning it as we continue on. For anyone that's in the programming, one of the programming classes, or is familiar with programming, this here, 2 double quotes, this is referred to as the empty string, okay? So it is basically the lack of a character, okay? It's still a string, so that is a data type that stores characters. Even though there are no characters in it, this is still a string, okay? Now, why is that important? Well, so we have a string, empty string, that represents no characters. 0, okay, what does that represent? That represents, the lack of a value, okay? And then in database, if you don't have a data type, well, there is a data type called null, which represents nothing, okay? You can't have nothing in your database in any of the field values. You can't ever have no value, okay? So if it is a field that can hold a string and you want to represent no value, you use this empty string. If you have this is pretty self-explanatory. Use 0 if you don't have, if you have 0 of something. And then there are very rare circumstances where you might use this data type of null, but in the examples in this class, we won't need it, but we want to try to make sure we don't accidentally include it anywhere, okay? So these are all things that represent nothing, no characters, no value, and no nothing. No something, I guess. It's very confusing, but it'll make more sense as we continue on. All right. So let's check the chat here. Looks like it's lagging a bit. Make sure I am on the right settings here. Okay. If you are experiencing slowdown or jitteriness, if you rewind the video a little bit, you can get behind the buffer until this solves itself, hopefully. Okay, no questions yet. Value-related terms. Okay, so, we have a database. The database contains data, all right? So just like we can store characters that we could organize into people's names. We could store, social security number, phone number, anything about a person, okay? That would be considered data. Right. That gets put into the database. Now, what you pull out to use is information, okay? So using context of the other data in the other fields, we can convert data into information. So, if you pull out you don't have to do this, but if you pull out your driver's license, you can see that there are a lot of pieces of data on your driver's license. For example, your height and weight, okay? If you just looked at those individually, if you just had a card that only had height of, 5'7", what would that mean, right? If it just had that one piece of data on it, does it mean you're 5'7"? Does it mean, whoever gave you the card? We don't know. It's not very informative. So, if you take all the pieces of data together on your license, it will, it's information. So, looking at this, can you figure out which field on your driver's license is the primary key? All right, take a look. Pause the video if you want to think about it and try to figure it out, right? And then I'll go ahead and say the license number, okay? Take a look at that value. What's special about that value, right? It's a bunch of numbers and dashes and a letter, okay? By itself, there's no meaning to this, but when it's tied to your name, it's what ties together you to your license, okay? So no one else will have the same license number as you. Imagine if people had the same license numbers. All right. But if I look at my license, it has my name, my height, and my weight. I know that that height is the person listed there. I know the weight is the person listed there. So putting that together is information. Okay. Now, in this class, we're going to make that distinction. Outside of this class, it's something that you should just keep in mind, but it will become common sense to you later on. So, okay. So, when we have null in a field, what that means is a missing or unknown value. So, generally, it gets put in there as an error. Okay. So, unless you are specifically putting null somewhere, and you encounter null, there's some problem somewhere. Okay. And it does not represent a 0 or a blank. And by blank, I mean that empty string. Okay. And the reason we don't want nulls is once we have our data input into the database, if we ever want to calculate anything using that data, we need to have number values first, and then if somehow a null gets in the equation, the entire equation will result in null. So we don't want that happening when we're calculating things. All right. So let me check the chat. Okay, we got 4 to 5 viewers. All right. Remember, if you have any questions on the previous homework or on any comments I might have made, make sure you ask them in the chat while I'm here, so you can get some answers, and I can show you examples on the screen. Okay. Anyway, I created these slides, so it's not really out of a book. So the first structure we're going to talk about is a table. All right. And I don't know why it says relation here. This should say entity. So let me open. So our entities that we created in our entity relationship diagrams will eventually become tables. Okay. And what a table is, let's say, so I'm just using Google Sheets here as an example. I'm going to put in some grid lines around this. Okay. So this could represent a table for me here. Let's do this one. Okay, so call this my book table. Okay. And so the first columns in your table, the first row in your table is going to be the names of your fields. So what kind of fields or attributes should a book have? What do you guys think? What information could you store about a book? All right, think about it for a second. Make this a different color so you guys realize it's a different thing. Okay, so we could store a title, maybe author, and year published or something, right? So we put in some books. So we have the book of Bob, the author is Bob, from the year 2000. We could have a book called Pillows Are Cool by Jimmy, and that came out last year. So as we continue on, be thinking about the entities that you've created for your ER diagrams, and be thinking about what attributes you would use for those entities, okay? And this kind of helps you imagine backwards what an entity is, because some people in the beginning get confused about the difference between an entity and an attribute. Okay, entities have attributes. Attributes are a single value, all right? So title would not be an entity. It would be an attribute, obviously. So I wouldn't have a title entity in my ER diagram. But if I had a books entity, it would have potentially a title, an author, and a year attribute. Now, there's one problem with this table, and maybe some of you have noticed. We're missing a certain type of field in here. Does anyone have any idea what field type we're missing here? So, one thing about designing a database is you want to maintain the integrity of the data. Okay, and that's just a fancy way of saying everything needs to have its own unique identifier so things don't get mixed up. Okay, so what if someone named Bob also wrote a book named Bob, okay, in the year 2001, okay? Now, let's talk about, we need a unique, to maintain integrity of the data, we need a unique identifier field for each record. Okay, so the records are the rows, so Bob 2000, this is one record. Okay, a record is an instance of an entity. So in the book table, this row is a book called Bob by Bob from the year 2000. Okay, so we need to decide, are any of these fields, could we use any of them as primary keys? So in the example here, we can't use title because these books have the same title. Okay, so if we ever needed to create a relationship between this table and another, we would have no way to tell the difference between these two books. Okay, so everything would break down. All right, so we can have if you can have the same values in a field, it cannot be a primary key. All right, author, Bob was the author. Are these the same Bob? Are these different Bobs? We don't know. We could have a separate author entity, which would convert into an author table, but we could not use that as a primary key because we have repeating values. Now, what about year? In this table, year does have unique values, so we won't have any overlap, but, you know, more books are going to come out. So if we add those to our list, theoretically, more than one book is going to come out in a year, right? So even though it's unique right now, we're not forcing it to be unique because we could have multiple books in the same year. All right. So we can't use any of these attributes, so we need to create our own attribute. And, you know, if you've ever looked at your textbooks or any book really, they have an ISBN. So, and those are supposed to be unique, I think. I always just took that for granted before. ISBN, is it unique? intended to be unique. An ebook, a paperback book, and a hardcover edition will each have a different ISBN. So, if in your database you need to keep track of the different versions of things, you could you could still use ISBN. Okay. If you're worried that it potentially could have two values that are the same, you should not risk it. So in that case, since it said that it's intended to be unique, if someone makes a mistake, it could cause a lot of problems for us. So let's just create our own field called book ID, and then we just insert a number. Every time someone adds a book to the list, we can just give it an ID that is only used to uniquely identify the books. Okay? So, if you remember, one of the ER diagrams was for a library. If you had a books entity, this would be potentially a finished table for the books entity. Okay, so what you're going to be doing in this section is going through your entities and relationships and creating tables. It's the next step, because once we have the tables, we can convert those to SQL, structured query language, and then that will translate everything we've created into the computer, okay? Into a well-oiled database, right? Okay, so tables, again, this should be entities here. This doesn't give me any editing tools. Okay, I'll have to re-upload that, so I'm gonna add that to my list. Fix slide. What slide is this? Doesn't tell me. Oh, here it is. Slide 6. And so, because I made this mistake here, I hope it doesn't cause you to learn this wrong. Hopefully if you watch this video, since I'm embarrassed to have a mistake on here, you'll remember that, and it won't be a problem for you. All right, fix slide 6, relation to entity. Okay. I don't want you to have to wait for PowerPoint to open and me edit that now. I'll do it later. Okay, so for now, this is supposed to be entity. All right. So table is basically the next structure down from a database. We have a database contains tables. Tables contain fields. The fields contain attributes or the data. Okay, and once we have that, each row is an instance of an entity, so each row represents one thing. And that thing is whatever the entity is supposed to be. Okay. So the tables contain the records and the fields. If you do any research or read the material, extra material that I give you, you may see records referred to as rows or even tuples. Okay, it's all interchangeable, those three. If you see fields, you might see this referred to as attributes, and you may also see this referred to as columns. Okay. Also, the order of the records in the table doesn't matter. once you have data stored in a database, you're going to have software that is going to pull out and organize the information. We will do that ourselves once we get to SQL, so you can see that. Every entity needs a primary key. All right. And that is a specific field. All right. So to save space and be more efficient, you want to try to use existing fields as a primary key, so you don't have to store as much information. But sometimes there isn't a good attribute for that, like we saw with the books, so we just create our own. Okay. Okay. So a field is the smallest part of the database, contains only one value. Okay. So that's really important, because part of the reason we focus on the design in the beginning of this course instead of going straight to SQL is there's a lot of ways to do this wrong and make it still work. And it's really hard to go back and fix those things. If you do ever end up getting a job where databases are the main part of your job, or dealing with a database or anything, if it's existed for a while in an organization, it's going to be nearly impossible to change it. And whoever built it may not have designed it even. So you may encounter something called an improper field. Okay. And the reason I'm going to talk about these is because we want to avoid them as much as possible. All right. I can't think of an example off the top of my head where you might do this. If you use these, I would guess it would be some sort of efficiency fix. So the slowest part of your computer is your hard drive, and so pulling information from the hard drive takes the longest time in a computer, so that's your bottleneck. So if we can make the data smaller or have to access less of the data at a time, we can speed up the slowest part and make things faster. And that's also a part of designing databases, is making it as efficient as possible. Okay, so what are these improper fields? Well, we have MultiPart fields, multi-valued fields, and I threw this one in here. It's different than a normal field. It's called a calculated field, but this is something we will use. But we want to avoid these two. So a multi-part field, all right, contains two or more distinct items within its value. Okay, you could also say that as contains two or more distinct values. Okay, remember, a field can only be one value, so as a workaround, you could make it a multi-part field. Okay, but I'm telling you this only so you can identify them and fix them. All right, so let's go in here. Let's do our author table. So maybe it'll let me copy this. And put it here. Yes, cool. All right. So we'll put name, birth, year, birthday, I guess, and address, just because I can't think of anything else. All I care about right now is this name field. Okay. So we had the author over here was Bob. Let's go ahead and let's pretend he has a last name here. We'll call him. This is Bob Roberts. And this is Bob Bobbins. All right. Let me check the chat real quick. Okay, we got 5 people still, nothing in the chat. So if you have questions, remember to ask. So, yeah, Bob, well, I can do this easier if I just copy. This is why using a spreadsheet. I'm going to have you guys use a spreadsheet for this exercise. It makes it a lot easier. Okay, so we have a problem in this table. I've created this name field, okay, and it has their first and last name combined. All right, so when you're trying to identify these improper fields, okay, you are looking for fields that have data that you could divide into more distinct values. So for example, here in the name field, we have both first and last. We could divide that up into two different fields, first name and last name, okay? And why would that be better? Well, until we start writing queries, it may not make sense, but for now, I'll just tell you, it will make your database more efficient if you do this. And it will make the developers not hate you. So this is, the top one is the before, okay? And this bottom one will be the fixed one. So first name, is she gonna get used to hearing that and like running to the door now? So because I haven't hard coded anything yet, and this is another reason why we do all this planning, it's very easy to say at this point, man, this is not going to be as efficient as this. I can change it. It'll be a minor change to the ER diagram, and you saw how easy it is. Just change, just draw it out this way. Just add two fields. Change the one field to two fields. Okay. Most of the time, when you're having any problems with your database design, the answer is always create a new table or create a new field to fix those problems. Okay. So we would want Bob over, whoops, here, Jim here, and so I'm going to explain this. This might make sense. Let's say I am printing out a list of authors, all right, and I want it alphabetized by last name, okay? Well, the way a computer is going to do that through the database is it's going to look at the first character in the value and compare it to the others to find where it should put it, okay? So it will sort off of the first value here. Do you see a problem with that if I want to sort by last name with this design? Think about it. It should be pretty obvious. Okay. Now, the first letter is not the last name, so it's not going to work. Okay. There is a workaround where you could code it to look for the last name in each name field. Okay. That means every time you want to access an author's last name, the computer is going to have to run extra code to get that. All right. And here we only have 3 records. So if we add 1 millisecond to every access here, we're going to add 3 milliseconds. Now, is that going to make a big difference? No. But if we scale this up, okay, how many authors are there in the world? All right. Multiply that by 1 millisecond. I don't think in your lifetime it would finish sorting that. Okay. But if we change it to this way, then we can just sort based on the last name field, and we don't have to worry about the first name. So that gives us the efficiency. And if we did it this way, it would work until we had too many records for the computer to handle. Okay, and this field, well, we're going to get to field properties in a second. Okay, so besides multi-part fields, we could also see multi-valued fields. Okay. We don't want that either. So, an example of that would be in our author table, it would be nice to know which books were written by each author, right? So, right now, just ignore any relationships between these tables. Actually, I guess I want to do it down here. I'm just going to get rid of these. Actually, I'll just copy this to a new sheet. I always regret deleting things later, so I'll keep that. Okay, so let's say we want to keep track of which books were written by which author. Okay, let's say Bob Roberts wrote one book. Okay, and he called it My Book. Okay, let's say Jimmy only wrote one book called Your Book. All right, and then Bob Bobbins actually wrote two books. Trees Are Cool and Yesterday is Tomorrow's Holiday. There you go. I did misspell tomorrow there. Tomorrow. All right. Now, in this case, we just created the problem we had before. Well, so this is a multi-valued field. All right. In the previous example, we had these are different pieces of data. Your first name and your last name are not related, except that you have both of them. Bob is just a name that anyone could have. Roberts is just a last name anybody could have, right? So those are distinct values. So splitting that up is easy. But, so this one was multi-part. So with multi-part, the values are different and distinct things, okay? With multi-value, you will have multiple values. We'll call this books now because we have multiple. And maybe you would separate them by some sort of symbol like a comma, okay? This is a multi-value field. And it also causes pretty much the same problem that multi-part fields cause, which is someone, either you or a developer down the line, is going to have to write code to chop this up and parse it into the individual books. All right? And again, it has the same problem with scaling. You don't want to have to make the computer do extra work. So we can't use the same thing we did for multi-part fields. Okay, so let's say we want to split that up into two fields. So we'll say we'll have a field called first book or book 1, and then we'll have book 2. Okay? And remember, this is what I'm showing you now is another wrong way to do things, so be thinking about why this is wrong. Okay. So in this case, we have, let me copy this. The lol looks the same. Okay. Okay, so in this case, we have two authors that have written one book, so that fits in there great. Bob Bobbins, he wrote 2 books, and that fits in this design. What if Bob Bobbins writes another book? All right. So Bob Bobbins is going to write another book. Where do we put that? Okay. By the time we're going to be adding that in, the database will have to have been completely created. And at that point, it's really going to cost a lot of money and time to go back and fix it. So you want to avoid getting into this situation in the first place. Okay, so, you know, how many books can one person write? I think, well, I was watching some documentary on, what is it, Scientology, and the founder wrote like 700 books or something. So if I had 700 fields here, because I'm not sure if that's the most books anyone's ever written, but then I could have 700 of these, right? But what if someone writes 800 books in the future? So this is unsustainable. We can't just keep creating a field. So to fix this one, instead of creating a new field, what we do is we split it into a new table. So let me change this. Let me show you the different levels here. And I think I might just have this example in the PowerPoint, and it should be faster to show you. So multi-part. Another example of a multi-part field is if you just have an address field. Can you identify any distinct parts inside of an address like this? Right? We could divide this up into street address, 123 road, or we could even divide it up into home number or house number or address number, whatever you want to call it, the street name or road name, the city, state, and zip. Those could all be separate fields. And we want to do that because that gives us more, a faster way to search things and creates a lot less work down the line, which is always good. Okay, so how would we fix that? We would just we would get rid of the address field and then create a field for each of those values. Okay. So multi-part, that's what that is. There's the example of how to fix that. Multi-valued field, okay? So in this case, we're looking at, this is a registration for, okay, this is a student table. So what that means is each record in this table represents a student, okay? And so we want a way to keep track of what courses the student is taking. So we don't want to do this, right? We talked about how many courses can you take, right? What is the max number of courses that you can take? Another problem with this is, with the max, we don't know, right? The rules could change up or down. Students could take all kinds of number of classes. The other problem with this is when you create a field, so here we have 3 fields, course 1, 2, and 3. The database actually reserves the space for this value. And so if you have a bunch of records with empty spots, basically you're just wasting space in the database. Okay, so I explain that down here. This is how you fix it. When you have, if you're ever doing something and you notice this isn't going to work because it's going to turn into a multi-valued field, And I can't just make that into a bunch of fields, because that will cause problems. What you can do is you just make a new table altogether. All right. So instead of storing what courses a student is taking in the students entity, okay, and the student entity should really only contain data about students, okay. What we can do is store information or create a table about registration, okay, and we can use the student ID and the course name. All right. And we can split this into two tables. Now, how does that help anything? Well, let's take a look. So up here we saw Bob was taking Math 101. All right. Take a look at this solution. How can I tell that Bob is taking Math 101 in this example? Think about it. Okay. Take a look at the fields here. The students table had student ID. What kind of field do you think that is in this table? That's going to be the primary key, right? Because nobody should have the same student ID. People could have the same name, so we can't use that. Okay. So we have the student ID that's unique. And then over here, we also have student ID in the registration table. All right. And this is not the primary key of student ID, or I'm sorry, of the registration table. Student ID is not the primary key. Why not? Well, if you just look at the values here, we have 3 2s right here. Okay, so it's repeating values, it's not unique. So we can't use that as a primary key. But what we are using it as is a foreign key. So if you remember, a foreign key is what a table uses to represent a relationship. So in the ER diagram, your diamonds that represent your relationships will cause foreign keys to be created. All right. So in this case, we know students and registration are connected by student ID. Okay, so here it says student ID of 1 is taking Math 101. Okay, student 1 is Bob, so Bob's taking Math 101. Okay, so we still have the information, but we have it in a way that we can scale. Okay, so here Jim is taking these 3 classes because he's student 2, and student 3 is Sally, she's taking these 2 classes. Right? Let's say Sally wants to take another class. We don't have to add another field for that anywhere. We only have to add a new record. Okay. Once your database is built and implemented, it's very easy to add, remove, and edit records. Okay. But it's very difficult to add or remove fields from a database. Okay. So basically, your fields have to be locked in before you can move to the next step. At this point, any records are just example data to help you, think about what you're doing. So, multi-value field. Where you might have the courses listed by commas, or if you see this, where you put them into different fields, that's not going to work. You just have to split it into a new table. All right. And what relationship do you think these 2 tables have just based on this? Think about it, and we'll come back if I remember. Okay. Just checking if there's any chat. Nope. All right. If for whatever reason you can't chat, please email me. And this happened in another class. For some reason, people couldn't chat, which would kind of defeat the whole purpose of doing this live. I'm just checking. did get an email, but it's not about this class. Okay. So how about if someone could just say hi, just so I know the chat works, that would make me feel a lot better. All right, so that's multi-part and multi-valued fields. You want to avoid those, or if you encounter them in your design or someone else's design, you want to fix those. All right. And everything that we're learning so far, actually everything that we learn in this course is only applicable to relational databases, okay? There are different types of databases. When I was taught database, like 99% of databases were using the relational database model. But now that we have apps like Facebook, Twitter, Instagram, relational databases are too slow, so you might have to use some alternate database for that. It's not replacing relational, it's just an upgrade for relational in certain applications. So Twitter, you're just attaching messages to a person, okay? You're not going to need very many tables or attributes to keep track of that. So you can kind of use a different, it's called NoSQL, and you can use a NoSQL solution and get something quicker like that. Now, when you are creating a database for a large organization to keep track of, for a school, for example, if you're keeping track of registration, students, courses, teachers, janitorial staff, other staff, faculty, administrators, you can see the tables are going to add up. And then that would be a terrible thing to apply NoSQL to, potentially. I will do look at an example of NoSQL. We'll look at MongoDB. And if you're really interested in this stuff, you can skip ahead and look at the article. But it talks about how NoSQL is not a replacement for relational databases, but they both have their applications. So it's funny, it's an article about how these people were creating an app to compete with Facebook, and they were going to use MongoDB, and it explains how the way they did it basically was impossible to work as a social network. Okay, and we'll talk about why that is when we look at the article. All right, so this other one, calculated field, these are extremely useful because remember, we're trying to minimize duplicated data in our database while maintaining integrity, which all boils down to we want it to be fast and efficient, right? So the more we can fit in to the structures and the more organized we can be with our plan, it's going to make it better. Okay, so there may be times when you want to use a calculated field. Okay, so in the example, I have calculating a sales total. All right. I guess I don't have I should create a picture for that one. Okay, well, we can just, I can whip it up here quickly. So, let's go back to the spreadsheet. This was multi-valued field. This was multi-part field. And I'll probably post this file in Canvas. So if you want to mess around with it, or if you're watching this video as a recording, you can open this up and watch me be frustrated with trying to move tabs. Okay, sheet 3. We're going to create a sales table. Okay. And we're going to copy the formatting here. Just to make it easier to see. Alright, so in our sales table, we'll keep track of the sale number, we'll keep track of what? Let's say we're going to keep track of the price. We'll say you can only ever buy one type of thing at this place, but you can buy multiple copies of it. So we'll give it a price. So we'll call it product name, price, and quantity. All right, and so, and then we'll have a total. All right, so sale number, we created that so we can have it as a primary key. We'll go apples, oranges, zebras. All right, so we'll say apples are $1, oranges are 50 cents, and zebras are $2.9947. All right. We go to the store, we buy a dozen apples. So sale number 1, the customer wanted apples, and they wanted 12 apples. Okay, at a price of 1, that's 12 bucks. So I'm just going to type 12 in there. Okay. And here, let's say we want 2 oranges for 50 cents each. That's $1. And we'll get 48 zebras. All right. And this is another reason why I use a spreadsheet here, because I can't do that off the top of my head. So there, for 48 zebras, it's $14,274.56. Okay, so this is maybe a way that I would think to set this up, but there is a way you can make it better. All right, so think about each field in this case as a piece, and what kind of data is stored in there. Okay, sale number, we're just going to increment that by 1 every time someone buys something. So the next time someone buys something, it's going to be sale 4. All right, and with the way this is set up, you as the person at the cash register are going to type in the product name, or maybe select it from a drop down, and then put in the price, put in how many they're buying, and then what did we put in here? What did I do to get this? What did I do to get the values in these fields? Okay, is this field adding any new information? Okay, that we need to store. Do we need to pull out? If I wanted to know what the total of sale 3 was, I'm going to have to pull this record. Okay, which means the hard drive will have to access and pull out 1, 2, 3, 4, 5 values. Okay, and then I'll have to grab this value out of that result. Okay, now there's a better way to do it, and that's by using a calculated field. Okay, so before and after. So instead of hard coding, or I'm sorry, instead of actually storing the total here, which I guess you are writing it to the database, earlier I talked about that the hard drive is the slowest part of the computer. And so whatever your physical storage medium is, a thumb drive, a zip disk, a floppy disk, CD, that's always going to be slower than the other parts of your computer because they have physical moving parts. All right. And computer nerds may say, well, what about SSDs? They're faster, right? They are, and so I did a little research in one of my other classes, and SSDs actually, so that's a solid state disk. It is, as far as I'm aware, it is a hard drive with no moving parts, so then you don't have to deal with the slow issue, so that's why they're much faster, but the technology they use to store data is, it wears down. It's like using a pencil eraser. You know, it's going to wear out and then it's not going to have an eraser anymore. So a solid state drive has very limited reads and writes compared to like a HDD with like a platter inside. So this background information is extremely important to understand if you want to delve deeper into this, how the different parts of a computer work, because you need to target the slowest part and make that efficient. Making the other parts efficient, you know, doesn't make a difference. If you have a 2-lane highway and it goes into eight lanes going 2 directions, you know, there's going to be a lot of problems there. A lot of waiting for that 2-lane highway. The hard drive is your 2-lane highway, okay? Now your CPU, on the other hand, that's a teleporter compared to the hard drive, okay? Getting the information processed by the hard drive and sent out to memory may as well be teleportation compared to the hard drive's 2-lane highway speed. Okay, so instead of storing this in the very slow hard drive and then pulling it out later, what we can do is actually just store this field as a formula. Okay, so we want to take, this is just price times quantity. And so you can do this now in your tables as you're creating your tables. And when we get to SQL, I'll show you how to implement this so that the computer will do the calculations for you. Okay, so you may say, well, why is, instead of writing and reading this value from, you know, only having to calculate it once and then reading and writing it, why is that better than, you know, reading and writing one less field, and then every time you access that record, the computer has to calculate out that total price? And it's simply because of the fact that the hard drive is the slowest part of the computer and the CPU is the fastest. Okay, so it can calculate, once we have the price and the quantity pulled out of the database, we can just have it do this calculation very fast, and we don't have to store it and we don't have to pull it out. So that gives us that shortcut that is much faster. So anytime you can use a calculated field, you want to, okay? And the only ones we're going to deal with, and I'm not aware if there are other ones, you have to, it's only ever going to be between fields that have the numeric data type. So this represents the value of 1, and this value, it represents the value of 12. That allows us to multiply them, right? And the reason I'm making a big deal about the value of 1 and the value of 12 in this case is because if we had a product called 1, that's not the value of 1, that's the name of the product. So that would not be stored as numeric data. That would be stored as characters or string data in the database. Okay. So I could not multiply product name by anything here because this data type would be, it's called alphanumeric. You have we can basically break down, there's a million data types, but we can divide them into 2 main areas that we're going to use, and that is numeric data and alphanumeric data. So numeric data is actually values, number values. Alphanumeric data is just characters, okay? So names and stuff, alphanumeric. Price and quantity, numeric. What about a phone number or a zip code? Think about that. All right, that one I'm not going to answer. You guys can ask me if you can't figure it out. Should I use an alphanumeric field for my zip code and phone number, or should I use a numeric? Okay, think about that. Okay, so those are the 3 types of fields, and we've got 10 minutes here. Check the chat. All right, thank you, Reed. I'm not just talking to myself here. Okay. Also, is this making any sense? Because when everyone's quiet like this, it usually means people are afraid and in over their head. So if there's something you don't understand, we can easily set up a one-on-one meeting, and I'll make sure you understand it. And if you're behind, it's still not too late to catch up. If you need more time on any of the assignments, even the ones that we've already gone through, just let me know, and we'll work something out. Okay. In 10 minutes, can I do in the next section? Okay. Keys, we've mentioned these already, but here's kind of your more formal definition. So, something I may not have mentioned, I think I did actually, when we were talking about many-to-many relationships, if you remember. How's the relationship handled when it's many-to-many? Well, if you have a many-to-many relationship, any relationship you're going to have to use foreign keys, okay, somewhere. In a many-to-many, you have to take the primary keys from the 2 related tables and you put them as foreign keys in a brand new table that just links the other tables together. All right. Those fields individually are foreign keys, but remember, every table needs a primary key. In that case, both foreign keys, or both fields combined, are the primary key. It's called a composite primary key. So your primary keys can contain more than one field. All right. You can design your fields first and then decide which one's the primary key. It's just a label you put on one of your fields. And that label tells the database to watch out if you try to enter in duplicate values or a blank. Because if you do that, it could really mess things up. So if you when we get to writing SQL, you will need to, in the code, designate your field as a primary key. That just protects the integrity of your data. So you can't get junk in there that messes everything up. All right. So if it's a composite primary key, it's a key that has more than one field. So for example, you can use composite keys in other places. And when I learned this, it was from someone who learned databases a long time ago. But they really wanted to get across that if you didn't have to create a unique number yourself, you could avoid having to use an extra field, which we've talked about why that's good. Okay. So I'm trying to see if there would be any. So you might have to think about how you would combine fields to do that. So we couldn't use title, remember, we couldn't use author, we couldn't use year because there's going to be duplicate values. Okay, so then we start combining. Could title and author be unique? All right, how do we test that? Well, can an author write 2 books with the same name? Could it happen? So I think it would be weird but there's really not much stopping that from happening. It would just be really confusing and a bad idea for everyone involved, but it could happen. So that's too risky. So we cannot use title and author together as a composite key. What about author and year? Can an author write or publish multiple books in a year? Yeah, so that's not going to work. The combination of those isn't going to be unique. What about title, author, and year? A three-field composite key. Would that work? Could an author write more than one book with the same name in the same year? All right. Probably someone who knows database or is a database enthusiast may have purposely written 3 books in the same year, maybe even on the same day, published on the same day with the same title, just to mess up our database. So that's too risky. You don't want to take any risks in your database. They're very expensive. Setting up a database right is very expensive. Okay. It would probably be very rare for you guys to get a job where you are creating a database for any kind of large organization, but everything we're looking at from the design perspective can be used for personal use. You can use it at maybe in smaller scale things, like if you have your own business. Most small scale things, people generally just use a spreadsheet. Database is a lot more powerful than a spreadsheet, and it scales way better. It's easier to search. It's just better all around, but it's more complicated to use. So in this case, it would be really hard to come up with what we have to come up with a composite primary key. So it's just easier to add another field in this case. And with the speed of things nowadays, it's not going to make that big a difference. Now, another problem is, let's say we did use all 3 of these as a composite primary key. If we ever had a relation between this table and another, the foreign key would, if we had to use this primary key as a foreign key in another table, we would have to include all 3 fields. So in that case, we're duplicating a lot of extra data. Okay, so only consider that if you're not going to be copying multiple fields as a primary key for using a composite key. Okay. I'm not even sure if I understood the last sentence I just said, but ask questions if you're confused. All right. We got 1 minute left. When was the due date on this? Oh yeah, you have this week to do that. If you need more, if you're getting close and you need more time, let me know. What else? I don't think for the assignment you need to know much more except field properties. So we need to go over field properties before you can finish the assignment. Oops. Okay, I don't need that anymore anyway. Okay, so let me remind myself what this even says. All right, so you're going to take the ER diagrams that you created in the last assignment. So remember, you created 10 of them, or you were supposed to create 10 of them, and you're going to you're going to choose create the tables for 2 entities. this can be fairly time consuming. So you're not going to want to wait. Also, when you're picking your attributes, if you have 2 or 3, so you have to have your primary keys and foreign keys, but I would like you to have, you know, come up with like 2 or 3 attributes for each entity that you create a table for. So, for example, if you had books, you could use author and year or whatever, or author and title. You can decide if you want to use all 3, you can. If you want to be exhaustive and really put a lot of effort into this and really think about it, you could go as many attributes as makes sense, right? Don't be putting stuff in there that is useless. But I'm going to limit this. See, I think maybe 1 entity per exercise would be fine instead of 2. So let's see. You can create the tables for 1 entity from each problem. Okay. It says include field properties. So for now, I'll probably just cut this out and put it into next week's assignment, and we'll push everything else back since I didn't get to go over it today, and then we'll just go over that Monday. Okay. So I will get rid of this file too. I'm just going to take this. All right. So remember, whichever tables you pick, you need to. We're over time now, by the way, so you can always leave because these are optional to show up. So don't feel obligated to stay. But if you're interested in what's going to happen with the homework, I'm doing it right now. So. My classes are very fluid, mostly because a lot of the material I teach changes even within the same semester. So I may have to adjust a lot of things as we continue forward. Due dates would only ever be pushed back, and if I add anything to an assignment, it's not. It's only because I want you to do well in the real world. This is I take my job very seriously, so if you need anything, let me know. And just remember, I'm not giving you this homework to torture you. I'm making you do this because it's going to help you a lot in any technology field you get into, just to be able to say that you understand it, even if you're not going to ever do it in your job. It just gives you a lot of value in the tech field, understanding this, because a lot of places are used to people just teaching themselves, and they skip straight to the SQL, and then they make a bunch of those mistakes that we just talked about today. Anyway, creating a new assignment. Put it in here. And we'll call it adding field properties to our fields. Okay. So this one with so this one's just going to change too. You're just going to have to create 10 tables of your choice from the ER diagrams that you created in the last exercise. So you're going to be creating these, okay? Let's do create one record for each table. All right, so that would look like if you had this right here, this top three. It has the name of the table, which is just the name of the entity, so you didn't have to decide that. And then it's going to need whatever fields you decide on. So it's going to have a primary key that you'll have to decide on. The foreign key, again, that's just the process of looking at how it's related to other tables. But if you already added in your primary keys and foreign keys into your ER diagram, you know what those fields are going to be. And so make sure you include those in your tables. And then add 2 or 3 other attributes of your choice. So, for example, if I wanted to add 3 for book, I could use these. If I wanted to use, what do we have here? Students, oh no, sales. Then, after you decide your fields, you will need to add one record. And so you saw how I did it. That's what I expect you to do. Just put in some test data, basically. And the reason I have you do that is because if you are deciding the fields and then you put in the test data, a lot of times you're going to notice, hey, do I really need this? Or it'll make you think about you need to, basically it's a preview of what's going to happen if you continue designing it this way. So if you encounter any issues when you're deciding your fields, like you have multi-valued fields, multi-part fields, then you may have to go back and change your ER diagram to fix that. Okay, it's just redesigning. And so every time you find an error, I mentioned this last time, every time you find a problem, you have to go back to the beginning and make changes to every step to represent that. That's why it's important to get it as right as possible, as early as possible, so we don't have to keep starting over. And this is something that someone might use for decades. And it would be a real shame to make any errors on something like that. Okay, in this class it's low stakes, and then if it's a personal project, it's low stakes. If it's for your own business, you only have yourself to blame. But if you're working for someone else, you want to make sure you understand how to avoid these mistakes. Okay, anyway. Where did it go? Here it is. That should be that should actually be fairly simple to get done by the 25th. Since I took the field properties part takes a lot longer. And that's why we're going to spend a whole week on that too. That's extremely important for the design. All right. Did I keep what I cut in the clipboard? I hope I did. All right, cool. All right, so add your field properties for each field in each table you created in the last step. So you only have to do 10. I think the first time I had this assignment, you may notice some of my assignments in some of my classes are just a lot of practice, just a ton of practice. And that's because I don't teach this as you learning the theory. I teach it as you learning a skill. And so that's why I'm all about processes and the exams a lot of times will test your ability to complete the task. Not, I have to include some questions about the terminology, but it's pointless to just memorize all this stuff. We're going to keep doing it and doing it, and so it'll be burnt into your mind. You won't be able to forget it. It's like riding a bike, programming, designing a database, and implementing it. Every time you do it, it'll be easier. But anyway, I'm cutting back on the number of exercises, so, because, you know, I have to grade everything I assign you, so this makes it a lot easier for me and you. That being said, if you want to do more than what's listed in the assignment, you can, and I'll take a look at it for you and give you feedback. So, you'll be submitting file. And what's next week? It is, it's October 2nd. So I'll at some point push back the other due dates. Hopefully I remember to do that. At some point I will. All right. Okay. Last thing is, if you want to use spreadsheet software to create your tables, makes it easy to edit and just, it's easier to manipulate, I find, than like Word. You can use Word too if you want. If you want to use Google Docs because it's free, Google Sheets, what you have to do is, after you're done, you're going to have to download as an Excel file, and then you could submit that. Okay? So you can use this. It does make Excel files, and you can send those to me. All right. I think that's everything for now. Thank you, Reed. Just send me an email every day until you notice it done. So, how are you guys feeling about the class? Are you worried? Are you excited? What are your feelings here? I'll cut this part out of the video at the end, but I'm just curious how you guys are feeling about this right now. I do make a big deal about the material I cover in my class is all stuff that people do. None of it is going to be... If it's something weird, I tell you. Kind of like... there was like one thing that I mentioned. Oh, the difference between data and information. You're probably never going to need that outside of this class. But maybe you do. Who knows? All right, I'm going to soon read that means everything is the best and everyone is happy. If you're not, just email me and I'll help you out. I can do one-on-one Zoom meetings with screen share, guide you through things. Just let me know. All right, have a good day, and I'll see you guys on Monday.